Good evening. Today we are going to study our topic on latch, and these are of two types as shown: NOR latch and NAND latch. As shown in this circuit diagram also, we are having NOR latch and NAND latch. What latch basically is, it is the basic storage element, and it latches either a 0 or a 1. That is, latch has a property that stores the binary information in the form of bits. That is, it is able to store a 0 or a 1. But as you can see that we are having NOR latch and NAND latch, they differ in the way the inputs are connected. In NOR latch we can see that we are having the inputs connected as R and S, whereas in case of NAND latch we have the inputs connected as just reverse of the way like in NOR latch. So this is the main drawback, and this is only the disadvantage, because the way these two circuits are connected, this might change the way data is stored in the outputs also, and that may be because of intentionally or it may be accidentally as a result of some other circuits are being connected to these NOR or NAND latches. So as a result of that, the data gets changed. So in order to overcome this type of disadvantage, we make use of clocks which are connected in these latches, and we are going to discuss in detail about how the clock does control the operation of these latches. We are going to study that in our topic on flip-flops. So now let us switch our focus on to the latch, and in this particular video lecture we are going to study mainly the NOR latch, how the working of NOR latch is taking place here. So before we begin our working of this NOR latch, we must keep in mind the truth table of NOR gate. As all of us know that this is the truth table of NOR gate, in which you can see that the main thing to notice here is that if any of the input is 1, the output we are getting is 0. So this thing we have to keep in mind, and when both the inputs are 0, in that case the output we are getting is 1. Fine. Now let us take our case 1, in which we are going to make S is equal to 0, R is equal to 1, and now we have to see what the outputs Q and Q bar will be. Okay, so make S is equal to 0 and R is equal to 1. So when we make S is equal to 0 and R is equal to 1, here I am writing the first case: S is equal to 0, R is equal to 1. Okay, now since we already know that when any of the input is 1, like in this truth table, when any of the input is 1, the output will be 0. So here when it is 1, it will cause Q to become 0. Okay, so I am writing over Q to become 0. So now this 0, here we are getting 0. Okay, since this is 0, this is 0, so when both the inputs are 0, as you can see over here, this gives the output as 1. So we are getting Q bar as 1. So I am writing here Q bar as 1. So this is the way we are getting the outputs. When S is equal to 0, R is equal to 1, we are getting Q is equal to 0, Q bar is equal to 1. Now, so just imagine that when S is equal to 0 and R is equal to 0, what will happen? Suppose we consider this one. Now this is 0. Okay, this is 0, this is 0. Okay, so and we are having Q as it equal to 0. So this 0 over here we are getting 0, this we have considered to be 0. So when both the inputs are 0, in that case this will cause output to be 1, that is Q bar we are getting 1. So Q bar we are getting 1, and this 1 over here, from 1 over here to here we are getting 1, and when this is 0, this is 1, in that case we are getting q as 0. So I am writing over here. So you can see that there is no change when we remove the inputs, or when s is 0 and r is 0, there is no change in the outputs, that is the output which was there earlier, and it is the same. So this is also known as a memory state, or there is a no change state. Fine. Now let us take or consider the second case, in which now we are going to make s is equal to 1, r is equal to 0, and we are going to see what the outputs are going to be now. So now let us consider here s is equal to 1 and r is equal to 0. So I am considering second case, in which s is equal to 1 and r is equal to 0. Okay. Now on the same principle as if any of the input is 1, just like over here, the output it is going to be 0. So when this is 1, this will cause q bar to be 0 now, and q bar is 0. From here the 0, so let us first write here q bar as 0. Okay, so this 0, so here we are getting 0. Okay, now this is 0 and this is also 0. When both are 0, in that case we get output as 1. So the q output we are getting it as 1. So I am writing here q as 1. So this is what in case 2, when s is equal to 1, r is equal to 0, here we are getting q is equal to 1 and q bar is equal to 0. This is also known as that the flip-flop or this latch is set, and in the case 1 it is known as that latch has been reset in this particular case. Now again, just like we had considered in our case 1, we will consider the same case in which we are going to remove the inputs which we had given here, that is s is equal to 1, r is equal to 0. We got q is equal to 1 and q bar is equal to 0. So now what we are going to do is we are going to remove these inputs, and then we'll see how the output behaves now. So now make s is equal to 0, r is equal to 0. Okay, so this is 0, r is 0. Okay, and from here, now in this case we are having q as you can see, q we are having 1. Okay, this one here you are getting 1. Okay, this is 0, and we know that the output will be 0. So q bar we are getting 0. Okay, so let me write over here q bar as 0. Okay, this is 0. Okay, now so this 0 over here, here we are getting 0. So now this is 0, this is 0, and when both are 0, the output is 1. So q we are getting as 1. So here I am writing q as 1. So you can see that this is again the state is known as memory state, as there is no change in the outputs. So this is what? This is a memory state, or it is a no change state. Now let us consider the third and the very interesting case, in which if both the inputs are 1 1, that is if s is made 1 and r is made 1, so what will happen in that case? As you can see, suppose, and somewhere we know that if any of the input is 1, it causes output to be 0. So what will happen if we make both s is equal to 1, r is equal to 1? So somewhere this will cause q bar to become 0 and q also to become 0, which does violate the principle of a latch, or it violates the principle of a latch or a flip-flop, since the property of these are that they maintain normal and complement outputs, that is they have to be either 0 or 1 or 1 or 0. So when both S and R, if they are made 1 1, in that case it tries to make Q is equal to 0 and QR also equal to 0. Okay, now considering another aspect in which, now if suppose both the inputs are removed like we had done in our earlier two cases. Now let us imagine that these two are 0 and we have removed the inputs S and R, that is S equal to 0 and R is equal to 0. So now we'll have a look at this circuit diagram. What will happen? This is 0, this is 0, both are 0, and we have removed the inputs, that is S is equal to 0 and R is equal to 0. So now there are again two cases are there in this also. In the first case we are going to consider this Q, okay, and in the second case we are going to consider Q bar as the output, which will be obvious right now as we are going to see the working how it operates. So now when this is 0, this is 0, and also here we are having both the inputs we have removed. So let us take this one as first. We have to consider this one and we are going to analyze the circuit. Here we are getting 0, here we are getting 0, and we know somewhere that when both the inputs are 0, the output it's providing is 1. So this will cause Q bar to become 1. Okay, so I am writing here, this will cause Q bar to become 1, and when this Q bar 1, here we are getting 1. Okay, this is 1, this is 0, and we know somewhere that if any of the input is 1, in that case we are getting 0 over here. So when we consider this, so the output will be like here we are getting 0, so I am writing here. Okay, now let us consider the second case. So now we will consider Q bar and then see what output it provides to us. Okay, so we know that both the outputs are 0 0 and inputs are 0 0. So now considering Q bar as the output to consider first, let us see what happens. Since this is Q bar is 0, okay, now this 0, this 0, okay, so this will cause Q to become 1. So I am writing over here Q to become 1, and since if we consider this has become 1, now this 1 we are getting 1 over here, and this 1 and this 0, this will produce the output to become as 0. So this will produce output Q bar to become as 0. So the point here worth noticing is that when both the inputs have been removed, or when S is equal to 0 and R is equal to 0, we are having two types of outputs that we are getting over here. That is, in this, here we are getting Q is equal to 0 and Q bar is equal to 1, and here we are getting Q is equal to 1 and Q bar is equal to 0. So this is invalid, and also this type of state is not used. So that is why in SR latch, when both the inputs are 1 1, that is not used, or it is known as an invalid state. And finally, to sum up all these operations of this NOR latch, this is the, we can call it as a truth table for the NOR latch. As you can see, here you are having S and R inputs, Q and Q bar outputs. Now we can see that when there is no input, or we have removed the inputs, that is S is equal to 0 and R is equal to 0, it is known as memory state, or we can also call it as no change, or the outputs are stored just like what was there earlier. That is why we have written over here is as before. And when s equal to, and it is known as reset, and when s is equal to 1, r is equal to 0, it is known as set. The latch is set in this case. And finally, when there is 1 1, this is not used and it is an invalid state. So this is all about the NOR latch. Now we are not going to discuss the NAND latch in detail, as the overall working is same what we had discussed in the NOR latch. The only difference lies in the way the inputs are connected. As you can see, here we were having R and S, here we are having S and R, and the operations or the working takes place in the same manner which we had discussed in the NOR latch. Yeah, but there is a change in the way the outputs are stored now. That is, here in the NOR latch, 1 1 was the state which was invalid state, but in the NAND latch, 0 0 is the state which is not used, or it is known as invalid state. And here we are having, when S is 0, here Q is 1, Q bar is 0, and when S is 1, R is 0, here Q is 0, Q bar is 1. And when both inputs in NAND latch are 1 1, that is known as memory state or no change state. So this is all about the latch, and mainly the NOR latch and NAND latch. Thank you.